everybody. Today we decided to host this lecture, maybe two. We see depending on how many slides we cover today, about C++ fundamentals for competitive programming. As I also mentioned before in the group, this will not be very rigorous type of lecture on C++, but it's more like some of the fundamentals which we think are required for competitive programming. So certain details are more like maybe we'll not explain them, but I think all the aspects which are maybe important for competitive programming will be explained. We hope today, maybe if it will be necessary, will be 2 lectures. Just for my understanding, how many people know the C language? Yeah. Okay. Okay, if you know C, it will be a lot easier in my opinion, but I think the knowledge of any other language is already a big start to learn C++. So for people that are familiar with C, they will recognize this type of structure of a code. Basically, in a C program, you generally have a main, then you have certain variables. You need to define certain variables. For example, here we define A and B as integers. Then we'll explain later what is this C in and C out. But the general structure is you have a main, which is basically which is the function which will be executed every time you run the code. Then you may have some other functions or methods which are called by the main. And then this include is basically a way to include all the main libraries of the standard library. So you can, then we'll see later, but this ACD++ header contains all of the functions which are to input, output, to sort and everything. But we will see some of these functions later. But generally, for competitive programming purposes, you just basically copy the first 2 lines in your code. You don't think about it. For competitive programming, for other usage, maybe in industrial sense, you need to understand maybe what these things are. But for competitive programming, you just copy the first 2 lines of this code, and you have everything you need in general. Then, of course, if you use the C or Java, then you know that every line needs to finish with a semicolon. In Python, you just indent and you don't use semicolons. But in C++, every time you maybe define a set of variables, you input, every time you have any instructions, you put a semicolon to divide these instructions that you write in your code. So in this case, we define variables A and B as integers, we input them, then we define an answer as A plus B, and then we print, which is C out, A plus B. And all of these instructions are divided by a semicolon. Okay. Want to explain this part? You want to explain this part or what?
Yeah.
Okay.
Okay. Input and output in C++. In C++, we have something newer than C, which is C in and C out. They are very simple. I put an example here. For example, you can use C out to print anything, a string, number, everything. And we have C in. And unlike the Python, the C out wouldn't print the \n, endl, or inter character at the end. And one good thing about C is that if you take 2 variables in the scene, they would be got by the scene, and there's no difference if the user puts inter between them, a space between them. The C++ would handle that, so there is no difference for that. That's what I wrote here. And some other useful things for input-output that you can search and learn by yourself. They are some of them are the same as C. Printf, scanf. There are some things to get to print something or get some input from the user which are the same in C and C++. And then we have getchar and putchar, same for C and C++. And after that, and we have getLine. As I told you, C doesn't care about endl or spaces or things like that. So if you want to get the line the user gave us. You just can use the get line. Cin. Cin means console input. The C stands for console and in stands for input, and cout is console output. We also have CERR, which is console error that you can use to print things for yourself, then they would not be printed in the judge console. And we also have other things. Fast IO means fast input output. You can when you are using only cin and cout and you don't use printf and scanf, there are some things that are the same from C and C++, and because of that the C++ is somehow in getting input a little bit slower, but with this command you can make it faster, the first one, and the second one, the third one, you can make it faster, but after using this you shouldn't use printf and scanf. It's not okay, it's not guaranteed to be okay. And if you wanted to work with files in C++ program, you can use file input output, file IO, which is here. You can use input.txt with free open, FRE open, and use the output string. You just give the stdin, you just give the type of the text and what you want to do. R plus means I want to read and some other things, and you tell it that consider that as console of getting input stdin, and then the output, it would consider output as console of output, the text.
I think out of all of these things, for specifically for competitive programming, you just remember that you use cin to input variables. So when you're given certain variables which are generally separated by a space, you just use cin for each of these variables. So maybe you need to input an integer, then a set of strings. You just do cin for each of them separately. C++ generic will allow you to do that, but we will show maybe an example of this. Then this also be more clear with examples, but the only thing you need to use are cin and cout, but they are generally slower than printf and scanf. Yeah.
When we want to get a character from the console, will it automatically skip the white spaces or not? Because, for example, in C, when I use, for example, scanf, and I want a character,
Mm-hmm.
if I just type %C, it will not skip the white spaces. And if I write a space and then %C, it will skip the spaces then. And how can I make this in C++, for example, with the C and
Generally, the way the input are presented in context is that if you have given an input where you have a set of characters that you need to input separately, they're generally separated by either new line or white space. But when you use cin, they will be taken as individual characters automatically. So basically, you can just loop on the number of characters that you need to input. You just do cin for each one of them separately.
Yeah.
Then, if you need to input also the white space, I think you need to input the string, right?
Yeah, usually in problems you don't see things like that because they are standard, but if you see something like that, you can use getchar like C. You should do the same thing as C because C++ is a new version of C. And in problems, I think I use getLine because in that problem you maybe getLine and save the line, whole input of the line in a string and iterate over that. So if you want the if character, you have the if character in that string.
Yeah, in general, like 99% of the time you just use cin and it will be clear what you need to do. Like you just cin whatever variables separately you need to input. But if you're familiar with C, with like scanf or printf, you can use them in C++, they work. But cin is more used because it's easier to do. But scanf and printf are actually more efficient than cin and cout. So people do usually, they copy these fast IO lines, which are iOS and cin-tie. You just copy this on the main, and then it will become faster. But in general, scanf and printf are faster.
Just a note on just sync with standard I/O. When you use that and you use both C++ and C style of inputs, it reads messy. So it usually reads first one type.
So use this with only with C and C out.
Yeah.
Okay.
Do not use printf and cout or this kind of
Not
message.
sharply different.
Okay. And variables in
Is the input clear? Maybe you want to see an example on this. Okay. Can you open an editor? If you have it here.
A caso?
Così che funziona.
Vabbè, aveva detto limp.
Okay. So see that? Okay. Can you see the code? Okay, okay. So basically what you have, this is a general C++ program. You have these the first two lines like I mentioned before, but you just include them, you don't need to know for context what they do. But when you include this, then you're fine with also with libraries that you need to use. Then you have the main, which is the main part of the program. And the main, you may have some functions that you call. So suppose that generally what you have is in a standard problem in competitive programming, you maybe have some input, which is generally you have n, which is the number of variables or some type, maybe elements of an array. So you define n, then you input n first. Now, for example, if n is 20, we need to input 20 as a n, which is the size of the input. For example, we input n, then we have assigned the value of n, the variable n. Then, for example, the problem gives us two numbers a and b. Tells us the problem. In this problem, you have two numbers a and b, and you need to output the sum of these two values. Then you can input a and b this way. So generally, if a and b are given as in a single line, you have a, then white space b, you can input them this way. The white space will be ignored, and they are separated by this. But also, if you have a new line, then it works this way. So, for example, the input may be something like you have n equal to 2. Then it means that you have two numbers. Then you can just input. Maybe you have 4 and 5 as a and b. Then n will be assigned as 2, a will be assigned as 4, and b will be assigned as 5. And then the output, as we mentioned, is just cout a plus b. Then you can just print a new line like this or like this. But usually it's preferred to use the /n to output a new line, because it's faster than n line, but it's fine either way. So this is a general idea. Then, for example, if you need to input, I don't know, 2 characters, then you can do the same.
What's happening if they separated by the space?
Characters.
Yes.
So, for example, if you have 2 as n, then you have
Yes, exactly like that.
if you define A and B as characters, you input them this way, you will get like the variable A will be equal to D, and the variable B will be equal to E. So they will be assigned separately.
So what if we want a string that want all the line, like a space?
Yeah, use getLine, but usually 99% of problem with characters, you don't have strings of that type, because they are made in a way that they don't require some particular input. But in some specific cases, you may need to input also that, but it's very, very rare. You just do, like you said, use getLine, like C. I think you can also use the C syntax, also C++. But for now, you just need to know this because those type of specific instances are not like very very rare. Obstacle forces never happens because the input is made in a way to be simple to get also. Okay. Okay, now we'll go to variables.
In C++ we have variables, and some of them are listed here. It's like int, long, double, character, booleans, strings, and the things I added here. It's about we have short int, we have long int. So adding a short thing before int means that it's a shorter int for using for smaller numbers, and long int has more space, so you can use it for bigger numbers. And we also have unsigned int and signed int. If you don't know about them, they are not important in our field, but you can go to this link and learn more about them. And it's just like, okay, int is an integer value that we use it for numbers, not very big numbers, and the int has 4 bytes, means 32 bits. One of them, the leftmost one, is for signing that, so it would describe if the number is positive or negative, something like that. And it includes this range of numbers, which are, let's just say, about minus 2e9 to 2e9, which is good. And but we usually use them for numbers minus 1e9 to plus 1e9 to be safer, to avoid overflow. And for bigger number, there's an example here. Okay.
Okay.
There's an example here. Something usual, getting two numbers and adding them and save that into the z. And that's it. And we also have long that we use. So it's long int, not just one line. It's long. It's for bigger numbers. You can add numbers up to this number. So you have, it has 1e18 capacity, so you can use it for numbers negative or positive from 8e18 to positive 8e to 18. It has 8 bytes and 64 bits, and as usual one of them is for sign, so this number is calculated by the 2 to power 63 minus 1. And there's an example here. If you had two big numbers like 1e9 plus 7, which is prime by the way, and 1e9 plus 9, and you wanted to have the multiplication of them, that would be something very large, something around 1e18. So you should use a long tag to save that, and that is what I did for the values. So here you can save the multiplication of two big numbers. And did I miss something?
No.
Okay. As I told you here, 1e9 or 1e anything would be a double value, but when you say that long x would be equal to 1e9, it would, C++ would automatically cast the right number to long, and x would be that number. We type long. And we have double for floating point numbers like pi, and it has 8 bytes, and this is the range we can use for that, but it's not precise for every of them, and it has some precision, like 15 or 16 digits. It would be different after doing some operation, so be careful with the double. Maybe you add two for adding it's safe, but for multiplication, when you multiply two doubles together, you lose some precision sometimes. So be careful with that. If you have some problems with like that in programming, you can also use long double. It has more precision because it has more bits in the memory and it includes a larger interval of numbers. That's the thing. If you want to know the construction of these variables and these types in C++, you can also search and read it. There's the exact thing, but the idea is that it would save numbers like 1e to something, so it would have the how large is the number, so it can have this number which is very big in it because it only includes 4932 in it, and it has something like that. To understand, that's the 10 to power that, and because of that sometimes it loses precision. Okay, next step. There is a sample thing. That number is with many precisions, and I use for one of them double for D, and for LD variable I use long double. And in the in this line I fix the number of the digits would be printed of that number. You can fix the number of digits that you want to be printed. Sometimes in problems it's useful, but usually 10 is enough in problems. And after that I printed the values of D and LD, and we can compare them, and we will see that after some digits the double value would lose the other digits, but long double wouldn't, because long double is more precise. And is it 4?
Yeah.
Okay.
Okay, just a quick note about when you use double integers. As Nima said before, when you have a variable of a type and assign an expression to that variable, it can happen that the variables in the expression are not the same type of the variable that you are making. So like in this case, we have a variable, we declare a variable b as a double, and we assign the value of a, which is an integer, divided by 3. So what C and C++ will do in the case in which you don't specify anything like this double and this dot 0 is making the operation. So 2 divided by 3, which is 0.6 periodic, and it will cut after the decimal part, so it will be just 0. In this case, we cast the value of a to double, so it will be like 2.0 divided by 3.0. This 0.0 is important because otherwise the compiler will see also in this case an integer value, so it's the same case as before, 2 divided by 3, and otherwise it will also be an integer. Yeah.
Isn't there automatic casting? For example, I knew that if we in C, if I just write a slash 3.0, then C knows that there is a 3.0, so a double, and then just casts a to.
I'm not sure about that.
I think yeah.
There is something like that, but if the variable type is int, it would cast it again to int. So
Okay.
it would be two casting. So be careful with the type of the values. Do you
So
understand?
okay.
No,
Okay. Okay, yeah. You were right. Okay, so yeah, it casts automatically.
Yeah, also you
Even
need to
if you
define
delete the pointer
double.
point zero,
What?
it would work. Delete the point zero. Yeah.
Yeah, without the point zero, it won't work.
It will work, I
Yeah.
think. Do it again. No?
No, I need
Because
to.
it does the integer division then converts the
Yeah.
Yeah.
Yeah. It will do on the right side of the equal sign, it would do the integer thing,
yes.
and
And
after that it would cast it to the double. Yeah.
Okay, so it works as you said. Personally, I'd like to specify when I do these things, because if you when you have parentheses, it can be messy. So the more you specify types in this type of expressions, the better.
yeah, it's more readable.
Yeah, also.
I almost never use casting in general. I generally define the variables in the most safe way possible. So if something may be a double, I use a double. So I never cast anything on because it's risky, and it may be that maybe it works for samples, but maybe some test case it doesn't work, and you don't know which test case doesn't work. So it's generally more safe to do as he said. So you define everything and don't do casting because it's not safe to do generally.
Also, at the beginning, doubles will be you won't encounter
Yeah.
doubles for easy problems. You will encounter them if you do like
Geometry.
computational geometry problems, which are a mess by themselves. And you have also precision problems, issues with it.
Generally, they start to avoid a lot in recent years. Problem with doubles because they are not safe for precision. So also probability problems, they generally like to do them with modular arithmetic. So I think it's very rare these days to find the problem with doubles sometimes, but especially in ICPC ICPC is almost certain that they have geometry problems or probability problems with doubles. So it's not too important to know this stuff right now, but
Yeah, but
it's may be useful in the future, of course.
we were saying now at Squarely this year there were 2 problems with doubles
Okay.
on
We can be
9 problems.
There are some type of bypassing these errors that in future maybe we will discuss.
Yeah, but for now just introduction.
Especially in codeforce, these places they like to avoid the doubles. People don't like them because they may have the correct logic, but they have wrong answer because of precision. People don't like it, so they avoid it. But in ICPC, generally, you have at least one problem with doubles or precisions problems like geometry, probability. So for those cases, it's important to know.
Okay. Characters are the type in C++ for storing only one character, so it would be something between 0 to 255. It uses 1 byte, 8 bits of memory, so it has 1 to 255. And the special thing about them is that the conversion of them to ints. So it should be using ASCII table. Yeah, we expect that, and characters are using that. So if you have character, for example, k in a char a, it would be, if you cast it to int, it would be equal to the 107. So for example, I think the next slide. Yeah. Here you can see the normal casting. So casting between characters and integers is very easy in C++. You don't need to use anything else. For example, in Python, you should use OR or CHR. But here it's, as usual, it just casts them. So here you can see the character C is equal to character A, so capital A. And after that we print that character that it would print the character A. After that we cast it to the ASCII value, and here we would see the ASCII value of capital A, which is I think 65. I don't know, something like that. So it would be very easy working with characters and integers and ASCII table in C++.
It's in C++, but it doesn't work in C. I tried.
Yeah, some of these things are,
Specific-
some of these things are just in C++. That's why we use C++ because it's easier and it's still fast. That's the output of that program. Next thing. Boolean. Boolean values are true equal to 1 or false equal to 0. The Boolean value would use 1 byte. It means 8 bits. It doesn't use only 1 bit. It uses exactly 1 byte. So some of these bits would be ignored, would be useless, but the Boolean value would get them in the memory, and that's the problem with Booleans. Sometimes you need some number of Boolean variables, but you would get the memory limit execution. And after that, the problem is that you are using Booleans and each bit is using 8 bits, so your memory would be multiplied by 8. In that cases, maybe in future when you are more professional, you will see these cases. You will use something named bit sets, but not useful now, but it's an important thing to remember that Boolean has 1 byte. And one important thing about casting. In C++ we have casting, as I told you, and for Boolean values, every number which is not 0 would be casted to true, and only 0 would be casted to false. So if you make a Boolean equal to a number, the Boolean would be 0 if the number is 0, and would be 1 if the number is not 0. Even -1 would make the Boolean true. We have a condition here. So that Boolean would be equal to that condition. That condition is 5 greater than 3 or not, which would be casted to Boolean, and that Boolean would be true or 1 in a Boolean spaces, so it would print 1 there. Was it clear? Okay. Strings are, as usual, like many other languages, they store strings. And unlike Python, in C++ we can change the if character of a string. So, for example, if you have a string, I think I have the example in the next slide. If you have a string hello in the variable word, you can change the characters, for example, the first character and the fourth character, first one to the J and the last one to the P, and it's okay, you wouldn't see any error, so you can change characters of strings. And next slide. The last good thing in C++ is pairs. You can make pair of 2 variables. Maybe they have different types, maybe they have the same type, there is no difference. For example, here we have a pair of a string and int, which name my pair, and includes, the first one would be Alice, a string, and the second one would be 25. So to access the first variable of the pair, you use dot first, and for the second one you use dot second, and you can change the first variable or the second variable like this and print them like that. So it would be
It's just like a linked list in the C, right? You just type the characters that has a int and the pointers. I can get it.
So basically there is a way to store pairs of different types together. For example, if you want to save in an array, then we'll see later what.
Pairs create a new type that has a string.
Basically, you save, they are saved together. So maybe if you have an array of pairs at ith position, you will have that specific pair, for example. So
How many
it's like you define a struct in C and then you use them in an array. That's the same.
struct?
It's like you have a struct and you define it that way.
in C++, we don't have to specify the length of the string when we initialize it.
No, we don't need.
No, you don't. You just define the string. You get the input, or you can just write the characters in quotes. So and it's automatically get the automatically if you use the method length, you get the size of the string, but you don't need to define the size
Yeah,
before.
you don't need, because in C we somehow use array of characters, but the string is the same thing but with some other things. So the length
It's
would
more of
be-
a vector, but
yeah.
the string is more of a vector, which is another type.
And why pairs are important? For example, maybe you have some pairs. For example, you have the name and the age, and you want to sort this data by age. So you can make the first variable of the pair equal to age, and the second one equal to the name of the I don't know, students or anybody. That would be an int and a string pair, and then you can just sort them, and they would be sorted by considering the first part first, and after that, if it was equal, it would be sorted by the second one. So in that case, then the students and their ages would be sorted by the ages. And
So like in every other languages, also in C++, of course, we have constructor like if and else, cycles like while and for. Here is just a brief recap of what they are. So in with if we can use conditions. If the conditions is true, so like the Boolean logic that also Nima reviewed before. If the conditions, which is the one in the parentheses, is true, the first scope, so the first block of code in the braces is executed. Otherwise, if we have an else, it will skip the first braces and will check this condition. Okay, so in this case, if age is greater or equal than 0, it checks these other if. So if age is between 0 and 18, with 18 excluded, it will print you are a minor. Otherwise, if it's between 18 and 65, it will print you're an adult. Otherwise, if the age is greater than 65, it will print you're a senior citizen. I think it's clear. I don't know how the detail I have to explain that, but
Yeah, it's the same as in also
Python,
Python.
every other language. Just the syntax. Here we have braces. A point that we can make here, it's every couple of braces creates a scope. So it's a block of code that we call scope, and the variables that are defined in a scope are not visible outside. So if in this else we create an integer a equal to 0, outside a
We
will
can
not
show this
exist.
also record maybe. We can show. So if we define a as true, if we have any condition, like any scope, for example, if something, then we have okay. So basically, the way it works is that any variable that is defined. Okay, this is not important. So for example, if we define a variable a here as 4, a 5, then maybe we have another if which is somewhere else in the code, but is later than the first one. Also for is the same, but in general any type of scope separated by brackets, curly brackets. If we define another A here, these two will be completely independent, unless we define A outside of the scope. So if we have some if conditions which are separated in somewhere in the code, we can define a certain set of variables there, and it will be completely independent from the other variables that we define, other ifs or fors or whatever. So these two do not contradict each other, and they are completely independent. But if we define A as here, then we will get an error because the program will tell us, compiler will tell us that you are reassigning A. So what we'll need to do is set A as 5 like this, then A will be equal to 5 at this point. I think in C it's the same, I'm not sure. I know that in Python it's not the same as this. In Python it's different.
Yeah,
But in I
C
think in C it should be the same.
Yeah.
Uh,
Okay, and it's clear. So we have also while loops. So there is an example, I think. Yeah. There is a condition. If the condition until the condition is true, the content of the while is executed. So in this case, can you guess what it will print?
1 to 10.
And then it's printed or not?
Yes.
So yeah, it's easy.
Also, I forgot this return 0. It's not you don't need to print return 0 in you don't need to use return 0 in
C++.
main. You don't need.
Yeah, in C++ you can also don't declare the main as int. Maybe the compiler will write a warning, probably. But
You don't need to return anything in general.
yeah, the main doesn't need
So
to
it's-
return. Okay. Then the for
So
loop.
you can declare it as void main.
No, I mean
I think
in
you
C++ you can also don't write anything before main, like main parentheses, braces, and the main, without defining the type of the main. It's a bit strange to do. I usually write int main and returning 0 because I'm used to do that, but it's not a problem. You can avoid to do that. Okay, so the for loop, it's more or less like the while loop, but it has a condensated syntax. So you have an initialization initialization of a variable, like for int I equal to 0, then the condition I, if we take the previous example, less or equal to 10, and then the increment I++. So okay, yeah, that's the same thing. The first for does the same thing of the while that we saw before, and the second one actually prints from 10 to 1, printed. Okay, so we can have jumps in loops. So if okay, we are executing a loop, and we want that during the loop, not at the beginning of the loop when the condition is verified. In the middle, if something happens, we want to exit the loop or jump to the successive iteration. What we can do is, in this in the first case, use continue. So the 5 will not be printed. It will jump directly to the first line of the for loop, which is the for itself. And then in the second example, the second example is actually different because it will print 10 2, 4, and won't print 3, 2, and 1. So break actually exits the 4 and continue starts again from the next iteration.
And you can use it also for the while. For the while loop. In while loop you can
Yeah, also.
say
Okay.
Okay, since we have time, we can start
Okay.
with the standard library.
Okay, so I think the main difference between C and C++ in practical usage in competitive programming is that C++ has the standard template library, which is a library of pre-written functions and data structures, some algorithms that you can use directly without writing them. For example, if you know C, you know that sorting is not pre-written. Also, dynamic arrays are not already pre-written in C, so you need to define a struct or whatever to use them. So it's not advised to use C in competitive programming because of this, because you will have to write sorting and many other things, while C++ already has them pre-written for you and you can access them easily. So as I said, this is what I said before. So what are the types? Like the main aspect and advantages of the STL are that we can we have the possibility to use dynamic arrays, which are the vectors. Vectors are basically like the C arrays, but they allow a lot more options in them. For example, we will see then in the next slides. Basically, they are a much better version of C style arrays. Also, you can use C style arrays in C++, of course. Then we can use sorting directly, like there is obviously defined the sorting algorithm by default, like Java, Python, other languages.
Sorry, what's the by default sorting array has a complexity?
It's n log n normally.
So it's use merge or quicksort?
It's
I think it's merge.
an hybrid sort actually.
What?
It's called, if I remember correctly, intersort. It's an hybrid sort which uses a piece of a quicksort for the first part and some other stuff like that.
and I know it uses merge sort at the same thing, and when the merge sort gets to the array which is very small, it would run a quick sort or something like that, and it's already optimized, so it's not just it, and it has some optimization in it to be very fast.
Okay, so I don't know how many of you are have taken algorithms and structures. If you remember from that course, the worst case complexity of quicksort is actually quadratic. It's not linearity. So in C++ it is optimized to do the worst case scenario in linearity.
Yeah. Then there are some data structures like the queue, the stack, the set, map. If you already studied maybe some algorithms, you know what these are. Otherwise, I think it's you just learn them through time, but they are generally easy to like.
Can you explain just the last 12 terms set and map?
Sorry,
Can you explain the last 12 terms set and map?
etc.
What?
etc. Set, map, etc. and other stuff.
No. I mean, what's set and map do? I know queue and stack array.
Okay, yeah, that will show in the next slides. So for C++, since you have them already implemented, you just use them. You don't need to know how they are implemented from scratch. Like for example, at queue you need to use implement a heap. The map or set are like the binary search trees implementations. You don't need to know how to write those from scratch. You just use them directly. Like most people in competitive programming don't know how to write set or map from scratch probably. Or maybe they know, but they're very complicated to do, and you don't need to do that. So the first important data structure is a vector. A vector is an array, but it has a lot more functions to it than a normal C style array. So you can create an empty vector like this, vector int. The type it can be also vector string, vector char, vector double, like this. And if you define it like this, initially it is empty. So it's like you define an empty string. So it's an empty vector, empty array with size 0. Then you can also define this vector with a size of 20. So basically, what this will do, it will create a vector of integers of 20 zeros. Of integers, long longs. Then if you define like a vector of a certain size of other types, it will create some other values. But the important thing is that you already reserve a size of 20 slots for this vector. And you can also write the elements like you do for a string. You can first you use the quotes to write a string and assign it. For a vector, you can just write all the elements you want to assign it to this vector inside these curly brackets. So if you define it this way, you have a vector of size 7 of these various elements. So vectors are zero index like the C arrays, and yeah. So also the thing is that the vector are dynamic arrays. So if you define a vector of size 20 or 30, you can also add elements to it. The way to add elements to vector is you write a pushback function, which basically adds an element to the back of the vector. So if, for example, if you have a vector of size 20, you can push back an element to it, and that will be a vector of size 21, where the element that you added will be the last one. So also you can, yeah, this is the way you do it. You have your vector, then you just push back the element which needs to be, of course, of the same type of the vector. So in this case, vector int, you will need to push back an int to it, of course. Then another thing about vector is that you can assign specific index of this vector, like an array. So for example, you can access the ith element of this vector and change its value, or yeah, reassign its value, like normal arrays. So nothing particular here. And so they work exactly like arrays, but with more stuff. Also, another things about C-style arrays, I don't remember if it's the same in C, but when you define an array, an empty array in C in the main, by default it will have some random values. But if you define it in the global scope, it will have 0 by default. So if you write an array like this, all of these 30 elements will be random values. So, but if you do the same with vectors, it will be zeros. So for example, if you write like this, this will be an array of 30 zeros. But if you define an array in main, it will have random values. So this is important to know. And also about vectors, if you want to define like a multi-dimensional vector, generally 2D vectors are used. 3D, not they are too long to write. But if you want to define a 2D vectors, the 2D array, sorry, as a vector, you just do it like this. So you define a vector of vectors. So this will create an empty vector of vectors. Then if we want to define a vector of 20 vectors, so a two-dimensional array where you have 20, you know that how many how many columns you have, so basically, so you do it like this. Then if you already know the size in advance, you can just do it like this. This will create a two-dimensional array of size 20 times 20. So 20, the first 20 is the number of rows, the other 20 is the number of columns. Then there are many other ways you can do this. If, for example, you can create a vector of string, or vector. So you can do many things with vectors. Yeah, you can. For example, vector pay int. Then you have an empty, like you have a vector of pairs of size 30 of pairs. Then you can also change individual pairs of this array or vector. You can assign, for example. But there's many ways to use vectors. It's a matter of practicing and trying, depending on the problem. Okay. Is the vector structure clear or?
We have pushback that at the integer in the back of the array.
Yeah.
We have a function that add in front of the vector.
Okay. For vectors, you can't. Right, you can add in front of
Yeah,
it.
push front. But it has some things like push front or vector.back, things like that. You can search and learn about
Okay.
them by yourself. But the first thing I should mention here, when you push front something to the vector, it would be of order n.
Ah,
So
okay.
if the vector has n elements to it, it would iterate n times, and it would completely make your program very slow.
Yeah.
Because vectors are somehow organized to handle pushbacks, not push fronts. If you want to use push fronts as well as pushbacks, you can use a
deck.
DQ, something
Yeah.
like that. DQ. There are some STLs you can search and learn by yourself. DQ, I don't know, priority queue, and things like that. But
So
for vectors, do not.
no, it's not recommended to use push front because it's linear, so it's very slow to do. But pushback is constant, so you can do pushback in a constant time for each element. So yeah, like in vectors you can do other stuff like erase. You can erase an element from the middle, but those type of operations, like the only operation which are fast are appending from the back and removing from the back. To remove from the back, you just pop back or something like that. But any operation where you change or add or erase element from the middle or the start are very slow to do, and are not recommended to do.
That would be slow because it's used to iterate over all of the elements in the vector,
Yeah.
and that would be slow.
Pressure from the back are constant, so you can do them in like very easily. So, like I mentioned, you can sorted is already implemented in C++, like Java, Python, and other languages, and it's n log n. It's very like efficient. And the way you sort an array, like a vector actually, the way you sort a vector, you just write it like this: sort v.vector.begin and vector.end, dot end. And you can sort also in from bigger to small, so reverse order with r begin, r end. So it will sort in the reverse order. And also it works for every comparable type in C++. So you can sort integers, but you can also sort strings. You can sort actual vectors between themselves. So anything that has a comparator defined, you can sort it. You can also sort a vector of struct, as long as you define a comparator for it. You can sort. You can do many things with sort. And the only important thing is that if you sort something that is not standard, like an integer or I don't know, an int or char or whatever, you need to define a comparator for it. But it's more like slightly more advanced stuff. Then you can also sort a C-style array, like the array that you define normally, like int a square brackets. You just do sort the array and array plus the dimension of that array. So for example, if an array dimension 30, you do sort a plus 30, so it will sort the array. Something like that. But normal arrays, I don't generally use C-style arrays. Some people do. I prefer to use vectors usually. But it depends on the type of problem that you have.
The thing I should mention here, arrays, the C-style arrays are faster than vectors. So sometimes you get TLE and you change the vectors to a big arrays which you don't use some of the variables in it, and it will be faster. Just to mention.
So there are structures that are already present in the STL are for example a queue. The queue is a data structure where you can push elements in this queue. So it's like a first in first out structure. The way it works is that you basically have this empty queue. You can push elements to it, you can push a certain number of elements to it, and you can only access the element that is older, the oldest element of the queue. Like yeah, the front. So like in a real life queue, basically. Like you have a queue to doctor. So like the person that will actually go to the doctor is the first one. So the first one that actually got there in the queue. So actual like computer science queue is like that. So you push elements to this queue, and you can only access the first element that you put in this queue. So you can retrieve this element. You cannot actually remove these elements, but any other element you can't.
So we append to the last and access it from the first.
Exactly. Yeah. You append to the last, and then you access the oldest element you put in the queue. So you push elements to the queue like this. So a queue, you can define it for integers, strings, chars, anything. So also a custom struct. It's because it doesn't have a comparator. Just put elements into it. So to retrieve the first element of the queue, you use queue.top. So you actually can retrieve which is the element that you put first in the queue. So the oldest in the queue. And then pop removes this element from the queue. So the queue will reduce its size by 1. And it's useful in many problems. So it's an important structure. And I think it's implemented through some tree type data structure, but it's not important to know to use it. Yeah. Also, like there is a stack, but it's like the opposite of the queue. A stack structure is the opposite of the queue, where you put elements on the stack and you can retrieve the last element that you put. So it is the opposite. But I didn't put it in the slide because it's not very important, I think.
The top is if you pop the queue, the top of the queue is removed, right?
Yeah.
Or
So the oldest element that you put in the queue. So if you, for example,
Actually, pop also returns the top element.
this is top removed.
so I'm pushing one and two in the queue. So if I want to print, for example, which is the top, this element will be 1, so which is the oldest element which is present in the queue. So it's something like this. But if you have, for example, a stack, basically the opposite. If we print the top element of the stack, it will be true. And if we pop, we will pop true. So it's the opposite of a stack, basically. It's a LIFO, last in first out structure. But I think queue are more important than stacks to understand. Then there is the map structure, which is the same as in other languages. Basically, it's I think in Python are the dictionaries or something like that. So the way to define a map is you define it like this map of type, and then you write the variable name, the map name. The first of the first type you define basically is the key of the map. The other is the value. The key uniquely defines the entry of this map. Basically, we can define, for example, a map of I don't know, a number of students. Then we can write in this map their grades, but the students will be unique. Like for example, we can use the ID numbers of the students and as the key. Then the value could be their grade or anything which is an integer in this case, but we can also define a map of int, string, int, whatever else. The important thing is that a map has unique values, unique keys. That is important. It's like in Java or other languages, it's the same. There are two types of maps. If you maybe study the algorithms, you know that there are like the hash maps and the binary search trees type of maps. So the hash map is defined as an ordered map because the way the hash map is written is with hash tables, so they are not sorted, the keys, while the normal map, which is defined as like a red black tree or binary search tree, is the keys are sorted in a normal map. They are sorted in increasing order. While an ordered map, they are not. But generally, for competitive programming purposes, it's prefer you should always use the map. At least you unless you know what you're doing, you understand how the hashing works. I recommend just use a map for now. So if you want to use a map, just define a map of int or whatever. Don't use an order map because it's there are some risks in problems, and unless you know how hashing works, it's not recommended to use.
Yeah, also in code process there are test casing and hashing.
Yeah.
So if you use another map, it will create, there will be a test case or more than one test case that will create a lots of collisions, and the another map will explode more or less.
So unless you know how to define your own hash function, just don't use an order map. Although the unordered map in theory it's faster than a map because it's constant access, and the normal map has logarithmic access. So in general it is faster, but for contests it's not recommended to use hash maps or an order map unless you know how to define your own hash function. So if you define this map, for example, you want to assign want to assign to a key x a value y. For example, x could be the ID number of a student. So we want to assign to the student number 5. We want to assign its grade as 30, for example. We do it like this: m of x equal to y. So it's like you access an array. Also, even if x is not defined in the map, so for example x is not there, like the idea of the student is not in the map, it will create it automatically. So you just you don't worry about it. You just will automatically create the key if it's not in the map. Then you can access it again if you want to change the value. So you can assign a value. You can also change it in a map. And also you can erase by key. You can remove this key from the map. This operation is logarithmic, so it's a fast operation to do, to remove a key from a map. It will remove also the key, the value, of course. Then the set is like a set is a container which contains unique elements. So every time you insert an element which is already there, it will not be added. So it will have unique elements, for example 1, 5, 10, but it cannot have 2 ones. And the set is sorted. By default it is sorted in increasing order. It is defined as a binary search tree variation, but the important thing is that the accessing elements of a set, erasing elements of a set, inserting elements on a set is a logarithmic operation, so it is fast to do. And yeah, also if you have already a certain number there and you insert the same number, it will not be added again. Also you can define sets of ints, strings, any type which is comparable. So if you want to create a set of a custom struct, you can do it, but you need to define the comparator. But for basic types like int, string, you don't need to do anything. You just put elements in the set, and you can erase them or access them maybe. Also in a set, you cannot access by index. You cannot access an element by its index. You either get the element by knowing which is its value, or you need to use lower bound or other functions which are more complicated, but I think the important thing is that you can insert an element to the set like this, and you can erase it by like this. For now, that's important for now. Also you can get the iterators for the first and last elements. Like I said, you cannot access by index in a set, but you can access the first and the iterator for the first and the last elements, which are pointers. Like if you know C, you know what a pointer is, but important to know is that
How can we know if how to what do we know if there is an element in the set? For example, how can for example in Python there is the in
there's a find method
Yeah.
for the
yeah, it returns a boolean basically. You can use find, so it's something like this set. Is it like an iterator or a boolean?
It's iterator.
Yeah, okay.
In sets we have 2 iterators, set.begin, which would be the iterator to the first element of the set, and set.end, which would be the iterator to the last of the set, not
like
the
this.
last element, the one after it. It would be
Something like this.
somehow it means that this is the end of the set.
Okay.
And if you want to check if there is for in the set or not, you use auto. In
Iterator, right?
C++, you can use auto
Yeah,
rather
okay.
than giving the type by yourself,
Yeah.
because sometimes you don't want to write it. And the define would run a binary search, so somehow it would go to find first element which is greater or equal
So
than
like this,
4
right?
and checks if it is equal to 4 or not. If it was not, it would return the end of the set, so it would be s.end. So if the 4 was in the set, it would return the iterator of that, the pointer, the set's pointer to that. If it was not there, the iterator would be the end of the set.end. So for checking that is 4 in that set or not, you can use the thing Hasan wrote.
Like this?
Okay, it's correct. I have a macro.
Okay. So basically, when you want to check if element is in a set, also in a map, technically, you write it like this. Like auto type is a way like automatically get.
Is it a pointer auto or it's
No, it's a pointer out. It's an iterator.
It's an iterator.
Iterator, not a pointer.
Iterator is a
For a set.
iterator is a pointer for sets.
And not only in C++ we have iterators for each data structure. So also for maps we have iterators, and
Yeah.
we
each
can
iterators.
define them as a C, for example, set star and E.
For sets, you cannot do that,
No.
but they are somehow the same. So for getting the value of the iterator, you use a star, and then you write the
Yeah, something like this.
iterator.
For sure. So basically, for example, this is the pointer. Like I said, if you want to access the first element of the set, you do it like this. This is the iterator to the first element of the set, to the start of the set.
You can also
But if you want to access the value, you use like this. For example, interval is equal to star it. This way you will get the value which is to which the pointer is pointing. But I think this stuff is more sorry?
they are
Right.
similar, but they are not the same thing, because sets instruction is a red black tree behind it, so it uses the pointers something
Yeah.
complicated behind it.
It takes some practice to know how to use the sets and maps, because there are some things that I think that are easy to misunderstand about them, like how to get the iterator for a start, how to get the values. Then there are some other functions like lower bound, upper bound. I think it takes a little bit of practice, but it's not hard. You just practice a bit to learn how to use them. But this is the general idea of sets. Then also there are multi-sets, which are like sets, but you can store multiple values, and it's the same thing, but you can store multiple values, and they are sorted. So this is another thing you can do. And like we mentioned, basically you cannot access generally iterators like containers by their index, except the vector and the map. But map, it's more like you access the value, not the index. And but you can iterate through containers, iterable containers. For example, you can iterate for a set, so you will iterate all elements for a set. You can iterate for a map, and you can iterate for a vector like this. You can iterate for a vector like a normal array with normal for like int or something. But you can also iterate like this. So suppose you have a container like a set, map, or a vector. You cannot iterate through a queue. Queue is not an iterable container. Also a stack is the same, I think. But for queue you can't iterate through it. But suppose you have a map, a set, or a vector, and you can iterate through the like pointers of not the pointers, basically.
Elements,
Yeah, you can iterate through it through the elements.
but they are sorted.
Yeah, exactly. But like this way, you are basically iterating through the elements of this container. But if you want to access the elements themselves, then you have to actually turn them into a value. So it's like For example, if you want to iterate for a set, let's say like this, for example. So now we are iterating through the elements of a set. For example, we want to know which is the print every value of a set. We can just print like this, something like this. But for maps is a bit different. For example, if you have a map, you can do it like this. But what you need to do, basically, when you iterate for a map, you're basically iterating for pairs. So if you want to print, for example, the keys, you will do it like this. Okay. So it's something like this. This is the only difference. But for set vectors, it's like I showed before. So yeah, I think that's it for STL. You have any questions on STL or?
For using this, we just need to include, you don't need to install anything.
No, you basically, like I said before, you just include this header, like the bit C++, standard C++, .h. You include this, then you have all the STL.
Then for using without writing every time STD, which stands for standard, we use also the standard namespace of C++, which is
Yeah.
more difficult concept with respect to the normal library, but take it as granted, use it, and it's better.
You just copy those two lines and
for C++, for complete programming, not for programming.
like if you're, for example, work in a company, maybe on this stuff you should know more. But for contests, it's totally fine, I think. For the purpose of contests, it's you just include those two lines and you're fine. So are there other questions on STL? Okay.
There's also, I don't know if you wrote it. There's a,
With templates,
yeah, I don't know
I don't think it's important. But
Okay, let me tell something about templates. There's a simple template. As we told you, you can use it for every problem. So you are not under any obligation to write it again. The first line is pragma, which is very advanced thing to optimize things. The second one, which is the first important thing, is include bits/stdc++.h, which is the library that includes everything. Some people use include iOS stream, and some things are not there. So always use bits/stdc++.h, and after that using namespace.std. As Francesco told you, we do something to avoid writing these things. And after that, I wrote typedef. Typedef, you can search it by yourself, but to make the story short, it would be replace every time you see the LL, it would be replaced with long because writing long, maybe you are too lazy to write long every time, so you just write LL. And I use the same thing for pair LL and LL, PLL, and there is a constant value there. The const means that I won't change this variable. It's just a thing that you can search more and learn more, but it's just const, and there is a max end, something like that. And there is a main part. Usually I write the return 0, but it's not that important. And this line is the line I first in the beginning I showed you. It would be IO, fast IO, and it would make the scene and see out faster. And in this blog, which I added the link, you can see others templates. Some of them are very complicated because they like that. And that was all. If you have any questions.
also, one last thing is that, like if you define a function, for example, first function works exactly like C. The way it works is that you define a type of the function, which is the type of value that you will return in the function. Then you have the parameters of the function. For example, you have these integers. They work exactly like all the other languages. The only difference is that difference between Python and C, C++ is that you actually have to write which is the type that you're returning. So if, for example, we can say return x plus y, which is an integer. But if you have an int function, you return a string or nothing, then it's an error. So this is the only difference. Also, like the function should be defined before main, like C. You define it before main and you use them in the main.
And for the just one line, we need to define that not quotations. What is this?
braces.
The braces?
Brackets.
Yes, brackets.
Yeah.
You always have to use brackets.
Yeah, of course.
Because in if just
It's another thing, completely different. For function, you have to define the scope with the braces.
Yeah. Of course, also there are the struct, which is the same as like in C, of course, struct something.
More or less.
Yeah, more or less.
It changes that you don't have to use a type def to not write.
I don't use them a lot, but also you can use classes, but these are more advanced, like
Also make
That's
mistakes,
fine.
but they are not important.
like these are more like the basis today. But there are some other things that you can learn, like classes, struct, and other things like that. But
They are not that useful.
for now, no. I think
You
not.
already know what you need for.
Like for problems at the start of community programming, they're mostly very few lines of code and nothing particular like this, for example. You don't even need to use function, for example. So yeah, that's it.
Just
There's there's this site which can be useful.
here you can search for things from the StartUp library, and also the methods that that data structure implements. So it's can be
Yeah.
useful to see the syntax, and usually this site or some other site it's available during competitions, also in place competitions.
Yeah. Okay. So this is like a description how to use set.begin, for example.
Yes, and there's
Also an
the
example.
complexity.
Yeah. Complexity is constant, so it's okay. That would.
Have a good night.